Thanks everyone for choosing this session. I am Bala. I'm a program manager in Azure CAT team based in Redmond. I work on hybrid connectivity architecture issues for customers. So today we are going to talk about hybrid networking features available in Azure and how those features are brought into Server 2016 SDN. Okay. Along with me, Balaji, he's based in Melbourne. He is going to talk about most of the Azure networking features. Then I'll switch over to the Server 2016. All right, a quick agenda. Basically, we want to say what is SDN, and then give you a brief intro into SDN, and then how Azure networking features kind of use SDN, and then we talk about all the major features in Azure networking, and then see how those features are now available in Server 2016 SDN. We'll do a quick demo of hybrid connectivity between Azure to our on-prem deployment. Okay, I think you would have seen this slide multiple times during the course of this event. Basically, what I'm trying to take away is Azure networking. Basically, it's built for hyperscale, for enterprises. It means highly available kind of thing, and then hybrid. Our strategy is mainly a hybrid cloud. So, how the networking features help you connect your on-prem to the Azure. So that's the model. So basically how these things happen is through a software-defined networking. Even each and every data center we have in Azure is built around these basic principles like security, basically tenant isolation and high performance for for the tenant's workload. So you have load balancers to scale up your workload, and then virtual networks basically to provide isolation between tenant networks, and the other thing is to provide the cross-premises connectivity, and all these things are like defined over the software. So you go to the Azure portal or you go to PowerShell, and you could create your own network. You can segment it into multiple subnets, and you can define security policies within seconds. And the hyperscale and global connectivity is possible basically because of the huge fiber network infrastructure we have across the globe, and also within Azure regions. And also we directly peer with 3,500 plus ISPs throughout the world, so that anytime you want to reach Azure through your local ISP, it will be just one hop away. So we have connectivity from all those ISPs, and we also have an express route connectivity through partners, and that provides direct connectivity to Azure bypassing the internet. And worldwide we have 35 locations we peer with our partners. So in terms of SDN, how these things are possible over software is traditionally in your on-prem network gears like routers, switches, we still have this management layer, controlling layer, and the data plane, but they are all tightly integrated. And in SDN, basically we abstract the management and the control and the data plane, so that, for example, if you want to define a security policy and say, hey, I want to create multiple subnets, you go and create your rules in the management portal, and that gets applied to as access control list in the Hyper-V vSwitch, which is where your VMs are connected. And then when the actual data flow happens, those policies get applied to the actual traffic. So to begin with, the basic building block in any networking in Azure is what we call the VNet. Basically, where you go and create your VNet, you can bring your IP ranges and define your network range for the VNet, and you can bring your own name resolution servers and segmentation, whatever you want to create within that VNet. Those things are possible. And also, you can also control, like segment in the front end can talk to the back end, or it should not, or do you want to allow incoming connection from internet, or you want to block them. You can define rules like that. That's basically the building block in Azure networking. And like I said, like when you create a VNet, then you have to say, do I want to provide connectivity to internet directly from the VNet? And what kind of name resolution that I want to have. And basically, Azure also provides the DDoS functionality. So in case you have a workload and it is getting a lot of unwanted traffic, the Azure DDoS devices would be able to detect, okay, this customer's network is getting unwanted traffic. And then because of our hybrid cloud strategy, we also give you ability to connect back to your on-prem network through either a site-to-site VPN gateway, or you can go and have an express route connection provision that can link your Azure VNet to your on-prem network. All right. So with this intro, we'll talk more in detail about each of these features. Balaji will talk about all these Azure networking features.
Check, check. All right. In this section, I'm going to talk about the key SDN features that are available in Azure. Right? So these features will show you what you can get out of Azure from a networking perspective. And most importantly, it actually shows you the scenarios these features applies to. A really quick agenda on just this section. I'll talk about how to build an efficient network in Azure, which starts with the basic building block that Bala talked about, which is about virtual network. And then we'll go on and talk about how to protect this network, a virtual network that you build in this cloud, and also essentially segment this network into multiple zones to suit your business needs. Right? And we'll talk about how about deep traffic inspection requirements. If you have a requirement to inspect the traffic and how that's possible in cloud world. We'll talk about some of the SDN features that lets you do that in cloud. And we'll touch on what are the relatively new high performance enhancements we have announced and how you can get the best out of that for your workloads. Finally, I'll finish it off with the hybrid connectivity options that you have when it comes to connecting this highly efficient and strong network that you'll build in Azure back to your on-premises environment. Right? So that's a really quick agenda. With that, let's go into the first slide, birth of a virtual data center. So myself and Bala are in this field-facing role where we work closely with customers a lot. And one of the emerging trends is now that there is always this essential IT, and there is this DevOps that's also evolving. Right? So as a result of that, what we see in the field a lot is an infrastructure like this, where there are multiple virtual networks that gets created. As more and more workloads are created by IT and the departments, either it can be your business units or it could be your departments or projects. So everyone now get to create a virtual network and bring their workloads into cloud. Now, what happens with this model is as more and more stuff are put into cloud, especially into the virtual network, there's a lot of duplication that happens here, right? Especially a good example would be all the security-related components. We're talking about firewall, IDS, IPS devices, even load balancers, that are essential in each of these virtual networks to be protected, to protect the virtual network. But then you wonder, like, how many times do we reuse these components in each of the virtual network, which are essentially under the same organization, right? So how do we avoid this duplication? And you also come across challenges like these, where someone decides to create a virtual network just because they have access to a subscription, and not necessarily a security savvy person, maybe an application owner who creates a virtual network and throws everything out to the internet without any regard for security. So that's the second challenge we often come across, right? So the questions we get asked often is, how as a central security team, I told you that, right? How as a central security team, I protect all my virtual networks, regardless of who owns it, and how do I make sure all these shared components can be just used in a common fashion? How do I make sure I consolidate all these shared resources instead of getting these resources deployed in each of these virtual networks? Which leads to the third question about, how do I make it cost efficient, right? And the answer is, as you guys already saw, one of the best solutions we have come up with to deal with this scenario is VNet peering. VNet peering is a method through which you are able to connect virtual networks together. Before we go into that one, into the VNet peering aspects, we need to take a step back and understand how the virtual networks can be connected firsthand before we go into VNet peering aspects of it, right? So for that, we need to take a look at what is a VNet. A VNet is a virtual network that you create in Azure. And if you host a virtual machine in that virtual network, that particular virtual machine is able to connect to all the virtual machines that will be in the same virtual network. As simple as that. Now, when it comes to connecting that virtual machine across to a virtual machine in a different VNet, then that's when we are talking about how do we do it. The first option here, which we have for a while now, is VNet to VNet connection method. With VNet to VNet connection option, you are able to connect two virtual networks using gateway appliances. So you deploy gateway appliances in each of these virtual network and connect these gateways through an IPsec tunnel. Pretty simple. And it works great, especially if you've got virtual networks across the globe. So if you've got a virtual network created in Australia and if you have another virtual network created in, let's say, in Europe or US, you are able to do that now with this method, VNet to VNet connection option. Now, one of the challenges, though, with this method is the somewhat limiting throughput issue we have with the gateway. The gateways aren't going to scale much. The maximum we can get out of these gateways in terms of throughput is about 200 Mbps at the moment. Right? So that's where we introduce VNet peering. With VNet peering option, you are able to connect virtual networks the same way as the previous one, but using a different method. So with VNet peering, you are linking these virtual networks using the high-speed Azure Microsoft backbone network. And as you see in this picture, you don't have any gateways involved with this method, meaning the throughputs and latency we are able to achieve are pretty impressive. So we are talking about a latency that we are able to bring down to about 25 to 30 microseconds, and the throughput is about like 25 Gbps, which is really high, right? Now with VNet peering, it doesn't stop here, because if you look back at the issue we initially talked about, how do we address this in this model? Well, number one, VNet peering lets you create your environment in a hub and spoke model, where the central IT guy, again, he is now able to create a big virtual network, a central VNet, central hub virtual network, where he can consolidate all these shared resources, like things like firewalls, things like IDS, IPS, and all those premium services which you would otherwise have to configure in each of these virtual networks can now be grouped into the central hub virtual network. And yet, you can let the departmental VNets or application VNets to peer with the central hub virtual network and essentially use the central hub virtual network as a virtual DMZ. And it works across the subscriptions, meaning people can still spin up their subscriptions, spin up their virtual networks, and still get the most out of this model. Right? One more good option you have with this model is the connections to on-premises, be it to internet, be it to other organizations, they all can be done in the central hub virtual network, meaning the central IT and security team can have better control over establishing this connection, making these connections, and applying the policies when it comes to allowing who can connect through this one. And a departmental VNet, let's say, has an application that they run in their spoke virtual network that requires connection back to on-premises where they have some database they need to connect to. Then they can utilize the connection that's already established in the central hub virtual network. So again, it solves multiple purposes, multiple problems, isn't it? Like the initial problem we talked about where it comes down to cost-efficient model here, right? So as you can see, we have a central IT still restored, and you still let the DevOps to grow and continue with what they do, and still you are able to save a lot of costs by not installing gateways in each of these virtual networks, and also by not having to run connections between all these spoke virtual networks. So that's the solution we have for solving all the common problems we see with the current model of connecting virtual networks. Moving on, let's talk about the other common question we get asked is about how do I protect my virtual network? Where do I start with this? So one of the common scenarios is like where we have a scenario like here, where let's assume this virtual network is owned by marketing department, where they want to host an application which requires connection back to their middle tier application and all the way back to a database that they host in their backend subnet. So obviously this requirement, this tells you the requirement that the application, the marketing application requires some sort of internet connection so people can access it, and then but then the internet connection shouldn't really be an option for the middle tier and backend sensitive applications and databases, right? So how do we achieve this sort of complex segregation and also make sure the access control is enforced? You can use a function called NSG, Network Security Groups. Is a layer 3 firewall offered as a service built into Azure, which lets you define these access controls where you are able to create specific inbound and outbound rules, which essentially let you allow or deny specific traffic based on 5-tuple access control entries. Thereby, you are able to not only just carve out your networks to different segments where your different workloads can be deployed, but you're also able to protect this network from both internal and internet traffic. Continuing with security, one of the other common asks we get is about how do I provide secure internet access to those applications that needs to connect to internet. So same example, continuing with the marketing application. What if the virtual machines that are hosting the applications in the mid-tier and backend the subnets still need some sort of internet access, for things like, common things like where these VMs needs to connect to Windows Update, these virtual machines may need to connect to certificate requirements, that kind of thing. They still need some sort of internet access, but then it has to be done in a very secure way. How is that possible? When people say secure way, it usually means, well, we already have a very well established internet access infrastructure. things like proxies, things like web and content filter solutions through which we want the internet traffic to go out through. And we would like to do that for the virtual machine that we now host in cloud. How do we do that? Well, you can now use something called force tunneling is another feature through which you are now able to redirect the selected traffic from coming out of your Azure virtual network all the way back through your on-premises infrastructure. So in this example, once you have a connection established with your on-premises infrastructure, you are able to, number one, block the direct internet access that's available for the virtual machines in Azure and get the traffic routed back all the way back through your on-premises infrastructure. Thereby, you are able to apply your internet access policies for the traffic coming out of Azure virtual machines as well. And moving on, next topic is about managing the traffic and managing the packets through paths through which my traffic flows. You know, you are able to do that pretty easily on premises at the moment. You know, if I have two applications exchanging sensitive data on premises, and I want that applications to go through a device which does some sort of compliance, you are able to do that easily. Now, how do I do the same thing in on premises? Going back to the same example where this marketing application is quite famous now, and they start to communicate with the backend database and starts exchanging, let's say, sensitive customer information, and which means you are required to now bring in a virtual appliance or a traffic inspection device through which you are able to, you need to be able to, number one, inspect the traffic or, archive the traffic, journal the entries that's happening between them. How do I do that? Well, by default, you need to understand there are certain paths that are already enabled in Azure. So in this case, we get the front-end and back-end traffic, or I should say the traffic between subnets is automatically enabled by way of system routes. System routes are automatically created out of the box in Azure, which enables a number of automatic communication in certain scenarios. But with user-defined routes, you are able to design your own path through which the specific traffic should go through. So in this case, you can bring in a virtual machine or network virtual appliance, things like Palo Alto or any deep traffic inspection solution that you may have. You're able to install that in Azure, and then you could create your own system. You can create your own user-defined routes and override the system routes. That way, you are able to pump the traffic through the appliance and be able to be compliant with the traffic. And you are able to do that for multiple traffic as well, just not between subnets, but for any traffic that's coming out of your virtual network, you are able to redirect the traffic through the appliance of your choice. So in this case, you are able to send the internet out through the proxy that you install rather than out through the Azure gateway. Now, one of the other common questions is about how do I load balance my applications? I've got multiple websites that I've hosted in the virtual machines in Azure network. How do I load balance it? It's pretty simple. So we've got something called Azure Application Gateway, which is a layer 7 load balancer, through which you are able to load balance multiple sites, just not a single site. So a single application gateway instance is able to load balance up to about 20 applications based on both URL and content-based request. Now, it can also do a number of things like SSL termination. So in this example, what we see is an application gateway that actually is hosting a couple of applications, and it only allows traffic for the paths that admins have allowed it to flow through, and it's not. So if you take a step back and try to understand what NSG can do, NSG lets you filter and allow only traffic to specific ports. Right? And typically 443, you're able to allow NSG to let the traffic in. And with application gateway, you are able to complement the solution where you can bring in an application gateway and say, well, all that's coming to 443 for these particular URLs, you can further restrict what specific path you would want the traffic to flow to, not everything that's available in 443. Right? That way, in this example, you are able to say the traffic coming for Contoso and Fabricam.com at 443, let's imagine, it's only filtered through for specific paths. Say for videos, it gets sent out to a pool of virtual machines. For images, it gets sent out to a pool of virtual machines. So that's really efficient way of doing application load balancing through a layer 7 load balancer, which, by the way, has been around for a while now, and it's quite popular. Now, what's new with application gateway is a security add-on we released quite recently, which is web application firewall. With web application firewall is again a layer 7 firewall, which is available as a SKU with application gateway. It comes with pre-configured CRS, core rule set, that deals with top 10 vulnerability attacks. So these rule sets will handle all the top 10 attacks that are identified by Mod Security and Open Web App Security Project communities. Right? So which is pretty impressive. The other thing you could do with web application firewall is you are able to put it into detection mode where it logs real-time data about what's happening and what's the attack profile like, which you can analyze, and you are able to then stop all these attacks by putting that into prevention mode, which is quite handy if you want to try the firewall before you want to just completely use it. And the other great thing with this firewall is it has got great integration with logging, where it can log the it actually can produce real-time logging, which can be archived into Azure storage and can be sent into Azure Insights for Azure App Insights for further analysis. And it now actually works with Azure Security Center as well, where once integrated, Azure Security Center would go on, connect to the web application firewall, starts gathering the logs, analyzes the logs for you, and tries to surface any important alerts in the Azure Security Center for you. So which is pretty cool, where it's not only just a web application firewall, it also has great components that are integrated that analyzes and tries to find you any alerts that you need to be looking at. So now that we looked at some of the key functions that lets you build a quite strong virtual network with security and all the ecosystem surrounding that, let's have a look at the accelerated networking functionality, which we announced quite recently. What accelerated networking does is or I should say, what accelerated networking is all about is where we are able to now offload a lot of networking functionalities to the hardware level, which was happening in the past at the VM host and VM session level. We are able to offload that to the hardware level, enabling virtual machine to virtual machine communication to happen almost like instantaneously through some sort of direct connection as opposed to going through multiple components. So what does it all mean to me? And what are the results of this one? Well, the results are, again, pretty phenomenal. What we can achieve with accelerated networking is you are able to get the virtual machine to virtual machine communication latency to about, again, 25 to 30 microseconds. And again, the throughput you are able to achieve with accelerated networking is about 25 Gbps. Right? So what does that mean to me? Where would I apply this? Well, think about all those resource-hungry, latency-sensitive applications, applications like SQL, applications like CRM or URP solutions. You are now able to host them in Azure and get the best use out of it by using this feature. As accelerated networking feature is currently in preview, which means it's available in select few VM SKUs in some select few regions, but you are still be able to sign up for this and play with this, and I can only expect that once we hit GA, it'll be available across multiple SKUs, general virtual machine SKUs. Now, to the last section. Okay, now we've built quite good network in Azure. Now, how do I connect this back to my on-premises environment? Because you can always expect that there will be applications running in both environments, right? Both places, and you want to be able to make sure you provide quality connections so you are able to run with both networks. The first option when it comes to hybrid connectivity is ExpressRoute. Now, ExpressRoute lets you to connect your data center privately through to Microsoft data center using a partner ecosystem. Right. When I say privately, I want to highlight that we are bypassing internet with ExpressRoute. Right. So you are able to choose different throughputs, right, from 10 Mbps all the way, 50 Mbps all the way back to 10 Gbps. So you get predictable performance, which you can plan for and utilize it for specific application workloads. Comes with pretty good SLA, 99.95%. And with a single ExpressRoute circuit, you are now able to connect to 3 different Microsoft cloud offerings, right from Office 365, Dynamics, and all the SaaS offerings to Azure PaaS offerings, where we are talking about SQL database, storage, and all the other PaaS offerings, to the virtual network and all the private offering that we are talking about at the moment. We do have a separate session just on ExpressRoute and the design around ExpressRoute tomorrow, so you're all welcome to come and join us tomorrow around 9:30 in room 7. With that, let's move on to the next option, which is the next hybrid option is quite famous, which is VPN. Right? So you are able to establish a simple VPN connection over the internet from your on-premise infrastructure to Azure. Pretty simple, isn't it? But what I want to talk about VPN option today is a couple of things which are quite phenomenal. The first one is we recently, relatively recently, we introduced the use of BGP protocol over this VPN connection. So BGP, as we all know, is quite dynamic, and it's a standard when it comes to routing. Now, what BGP brings in with the site-to-site VPN is quite sophisticated network that you are able to build in Azure. With the use of BGP, you are able to build highly scalable, highly available, multiple path, redundant networks in Azure. But it doesn't stop here. Now, the second option we introduced with this model is now you are able to connect all the way back to your remote data center as well. So think about it. You establish a simple, So you establish a simple site-to-site connection from your on-premises to Azure, and then you are able to use this massive Microsoft global WAN network that Bala talked about to connect to your remote site, which otherwise would have been expensive or maybe even impossible to connect through. Right? So we are coming up with more and more ways where you are able to leverage this Microsoft ecosystem, including this global WAN network. So when you put all these things together, what we have is a pretty efficient infrastructure network that stretches all the way from your on-premises to your virtual network that you build in Azure, where you still have the central IT who are able to manage things in the hub virtual network, where they stay on top of security, connections, and be able to impose policies and decide who's able to use what resources, and yet let the DevOps team to develop and run with their own subscriptions and act like a focal point when it comes to security. And add to that, role-based access control is another function within Azure which lets you to make this DevOps connecting to the central IT model possible, where Role-based access control lets you define roles based on task based on the roles that you perform and lets you execute those functions in Azure. Finally, a quick summary of what we went through. So we had a look at a bunch of SDN features, but the point being, you get best performance out of most of these features now. 25 Gbps, for example, is kind of getting us a norm. And you get the best SLA across all the hybrid connectivity options, I can say. And you get the improved security not only through the layer 3 NSGs, but also through the layer 7 offerings we've got. And we do have a lot of other offerings and other enhancements we make in those areas when it comes to Azure networking. We don't have time to go into this, but it's all documented very well in the public domain, or you could come and ask us once we go to the Q&A session if you are keen about any of these specific points here. With that, we're going to do a quick demo on how all these things which we looked at and work together, and what it actually means to you when you have to put all these scenarios together.
Thanks, Balaji. Okay. So we talked a lot of features here, and so instead of just listening to Balaji, if you can actually see how all these things come together, I thought that would be even more helpful for you. So what I have is basically this network setup. The left side is my on-prem setup, and the right side is my Azure network. Okay, this is the hub VNet that I have, and I have something like an application server running in the Spoke VNet, and Balaji talked about the web application firewall. So I have deployed a web application firewall, and it receives the request from the internet from this address. So basically you can right now go to this address from your browser, and you can see Contoso University app, and you can go to the student tab and create your student entries. It's a live one. So basically what it does is the web application firewall inspects the traffic and sends it to the web server here. And all these are basically, this web server is talking to a database server in my on-prem network, right? So, and at the same time, I want the traffic that is coming from this web server to my on-prem, or anything going from my on-prem to my Spoke or hub VNets need to be inspected with even more deep inspection. That's what we talked about, network virtual appliances. So I have a network virtual appliance that is installed in the hub VNet. And so what we are trying to do is, like, how can we manipulate all these routes and say, hey, anytime this web server wants to talk to this SQL database server, the traffic need to go through this virtual appliance, and anytime this SQL VM or anybody in this on-prem network wants to talk to this whole Spoke VNet, it has to go through the same VNet. And then for the hybrid connectivity, I have express route circuit connecting my Azure VNet to my on-prem network. So this is my setup. Let's look at my actual okay, so what I have is in my deployment. So I am right now trying to take you to the app gateway, or the WAF, and here is the public IP that I listed in my demo slide. So you can reach this 104.42.197.112 address from your machine right now, and it is going to forward the traffic after inspection to a web server, and that web server address is 10.101.3.4. That is in my Spoke VNet. And then here is my Spoke VNet configuration. This VNet is basically the 10.101 range, and I have the hub VNet, which is in the 192.168 range, which is having the NVA and as well as my hybrid connection to my on-prem network. Okay, and then a quick look at the NVA configuration, and basically this is basically another VM. So instead of just putting a firewall thing, so I just created a VM. I installed Wireshark on it. So anytime my web server talks to my SQL DB on-prem, because I have manipulated the routes to go through this NVA machine, I will be able to see the packet. So we can do a Wireshark capture and see what traffic is going through that. And the way I am able to manipulate this is through what we call the user-defined route, or UDR. We talked about two places where we defined UDR. One on the web front end. Whenever the web front end wants to talk to the SQL, it needs to go to the NVA. So that is what this rule is saying. So basically, the 10.100 is my on-prem range, and it says anytime this web front end wants to talk to the on-prem range, it has to go through the appliance, which is in the hub VNet 192.168.2.100. And then it is applied to the 10.101.3 subnet, which is where the web server is present. And then I have another user-defined route that is for the return traffic. Anything coming from my on-prem, before it reaches the spoke VNet, it has to go through the gateway subnet, because I'm connecting through the express route gateway. It is in the gateway subnet. So I am applying another UDR in the gateway subnet and say anytime the gateway subnet puts a packet to the on-prem, the spoke VNet, it has to go through the same appliance. That's what this UDR here is trying to do. And just give you an example of this basic web app. Any client from internet reaches the web app, and it is talking to SQL DB, and the SQL DB address is 10.100.1.4, which is in my on-prem. And here is the actual application. So if you go to that 104 address, you can go to the student tab and create your own new record, and I can say so once I create, and I just basically just select a date, and okay, once I create this, let's take a look at the actual on-prem side. And before that, let me look at this particular thing. This is my NVA, so where I am running the Wireshark. And basically, since I am capturing the traffic, it is trying to capture any SQL traffic like port TCP 1433. And it is able to see the traffic coming from my 10.100.1.4, which is my on-prem SQL server, to my web front end, which is 10.101. So because of the UDR rules that I applied, now the traffic from the web, instead of going directly to the gateway, is able to go through the appliance, and the appliance could do the deep inspection and say, hey, is this really the proper traffic? Is it going to be allowed? You can define further rules in the appliance and allow or deny the traffic. So that's pretty much the case. And just for, this is my actual on-prem SQL server. So if I open my SQL administrative console and go to the actual database, and if I want to look at the students' records that's seen in the SQL database, I can say, show me all the records, and we can see all the records that are created. If anybody has created your names, you should be able to see that in this one. So, okay, so that's basically the live demo, basically trying to bring all the features together and how can you really publish an application and that is more secure. All right, moving on. Let's, this 8, right? So we talked about all Azure networking features, and now we want to say how all these features are now available in your on-prem data center using Server 2016 SDN. Okay, typically in your data center, this is how it looks. So you have a bunch of servers, you have hardwires, switches and routers, and maybe you have some load balancers. Everything is hardwired, and any change that you want to make is going to be very difficult. How can I bring this kind of agility to my data center? Basically, what customers really face in the field is anytime somebody wants to deploy a new app, they'll have to go through this configuration changes, and it takes time. And at the same time, those deployments will have to be secure, and at the same time, it has to reduce cost. These are the challenges customers face, and let's look at how Server 2016 SDN will help them achieve all these 3 goals. So right from Server 2016 early release, we worked with a lot of customers, and this is one of the customers saying how he was able to use Server 2016 SDN features and deploy his apps quickly and saving him a lot of money. So how all these things are possible? So basically what we are trying to do is we are trying to create these virtual networks on top of your existing physical infrastructure without modifying it. Basically, we are trying to use the underlying physical infrastructure and build our virtual network on top of it. And that is what the Server SDN features that we bring, whatever we have deployed in Azure. We are bringing that scale, and we are giving that enterprise-grade solution to your on-prem network. And let's talk about agility. So we talked about this SDN slide before, like because we are able to abstract the management plane, control plane, and data plane, we are able to define networks easily through software. And then in a typical case, like when you create a VNet and you create various subnets and you want to have access controls, you can easily define policy because now through the management plane, you define your policies, and then the management plane goes and applies these the rules into the VM NIC instance in the virtual switch. And when the actual traffic goes through these VM NICs, it is able to apply these rules and say, is this traffic going to be allowed or not? So you can scale this, but in a typical data center, you will have a lot of VMs, and there will be like billions of packets flowing through your network at any point of time. So how can we get all these things quickly? The basic building block in this one is the virtual filtering platform, which is basically a layer under the Hyper-V switch. And the Hyper-V basically exposes an actionable API that the network controller, which is the brain of defining all these policies, can go and write those policies through the VFP layers and whatever API, through the APIs that we expose. So within the VFP, basically there are 3 layers. One, we talked about VNet. When you create a VNet or when you create multiple tenant VNet, if you are in a hoster scenario, how do we kind of provide separation between one tenant network to the other tenant network? That is the VNet thing. And then you can deploy load balancers, so you will have some kind of a virtual IP that translates into some dedicated IP. So you have one public-facing web, and you will have multiple servers behind it, and so you will have to do the web to DIP conversion. So that's another layer within that VFP. And then third one is the security thing, what we saw in access control list or NSG. The NSG, these are the 3 layers that help you define the policy from from the controller. So in a typical case, when I want to do this, so I first want to create a VNet. And so remember, it is all happening on top of your physical infrastructure. So you may have a host, and you may have let's say take two hosts, and you have VM A and B in those two hosts. And first I need to make sure that the two VMs are able to talk through the underlying physical infrastructure. And at the same time, because there could be multiple tenants creating their own address space, and sometimes two tenant spaces can have the same address thing, but at the same time it should not clash with each other. So that is why we have some kind of an encapsulation method. We'll talk about that quickly. So the VNet layer gives you that encapsulation so that any packet from the VM leaves that host and it gets encapsulated, goes to the target host where the target VM is residing, and gets decrypted and comes out so that the VM thinks that it is talking to another VM sitting right next to it, right? And then the next layer is the, the VFP layer has the load balancer. If you have a WIP to DIP conversion, it also goes through and configures those tables from the controller to the load balancer NAT layer. And then the third one is the ACL, where you have actually the access control list. Once these things are done, a typical traffic flow happens through these various tables, and it consults all these tables, and then what is the actual end result, and it creates another table so that subsequent packets from the same source and destination can consult this table and say, hey, I'm going to allow this traffic, or I'm going to do the WIP to DIP conversion, or I'm going to do the physical to virtual IP address changes. So all these things can happen. That's why it can scale very well. You don't have to consult this top table every time. Yeah, you have a question. You are leading my next slide. I will cover that in just a moment, okay? Thank you. So I'm sorry, it's not the next slide, but I'll cover that in just a moment, okay? So a typical thing in Azure network, we saw the VNet, and we were able to see the ability to create access control list. The same thing is available because it's all the common API. We are bringing whatever you are able to, how you are able to define your network. The same APIs you can now target towards your on-prem deployments. That way you can have the same access controls, and you can have firewalls, load balancers, everything, whatever you have in Azure, bringing into your data center. How this is all possible? Basically through the network controller, which is where your management happens either through SCVMM or PowerShell. Or I also have a session on Azure Stack on Friday. Azure Stack gives you the same look and feel like an Azure portal. So you can manage your virtual network, you can define policies, you can create gateways, everything like the same way you would create in Azure. So you have three various ways to talk to this controller, either through SCVMM or through simple PowerShell script or through Azure Stack portal, right? And the controller basically applies the policies to respective host virtual switches to give you those policies. So this is another thing that we were asking about earlier in Server 2012 R2, between the physical address space to the logical or virtual address space, we had NVGRE for the encapsulation, and customers were asking us, hey, do you support VXLAN? And we now support VXLAN for the encapsulation between the physical and the virtual network. So basically what it shows is two tenants, red tenant and blue tenant, they have same address space, 10.0.0.5, and the target seems to be 10.0.0.7, but both are two different tenants, but they are all living in the same physical host. And when they communicate, how do we kind of separate this traffic? So which is the virtual network identifier piece. The header on this one is belonging to the physical infrastructure, and it includes, within that header, you have the actual VM's actual IP. The virtual network identifier belongs to this particular red tenant, and similarly, if a blue network wants to talk to its blue VMs, then the virtual network identifier is going to be different. This is what is going to be encapsulated and say, hey, when it reaches the target, and say it looks at the encapsulated packet and then looks inside what is the virtual network identifier, so it can put it into the respective tenant VNet. Another thing is common protocol is this OVSDB for provisioning the policy. So you talk about talking to the controller to define your policy. Now the controller will have to go and plumb these tables into the Hyper-V switches, and for that it uses another standard protocol, OVSDB. And even to talk to the controller, these are, we talked about SCVMM or PowerShell. Basically, these are again standard-based REST APIs to define your policies. So the next topic, so we talked about VNet isolation. Then I want to go to the next major thing, like whatever you have in Azure, creating a gateway to provide on-prem connectivity. We have the same gateway available in Server 2016. And this particular gateway, the important thing is now in Server 2012 R2, we had the same multi-tenant gateway, but it's kind of a 1:1 or active, passive kind of thing. So it was, if one gateway fails, the backup gateway comes live. It's not active-active in Server 2012 R2. But in Server 2016, we now have M+N resiliency. So what it means is you don't have to have a gateway for each tenant. You can have one gateway that can take traffic for a lot more tenant networks. And or if you have more virtual networks or more tenancy, you can add more gateways. So all of them simultaneously could take the gateway traffic, and based on which tenant, it can redirect to the respective tenant network. Then if one of the gateway fails, it can automatically fail over to the remaining gateways, or if your load increases, you can add more gateways dynamically. So that gives you the M+N resiliency. So yes, the controller can define all these things in your
policies. We're going to define everything on there, because back in the days, I think we had the same question. Like we used to have like NVGRAs define everything on the power shares, put all the IPs, and then when you add a new tenant,
okay,
you have to go all the servers through again.
Yes.
With the new tenant. So now we don't have to define anymore.
Yeah. So you can do that again through SCVMM is the easiest way to do. And SCVMM talks to the controller. Controller can say, hey, this is for a gateway that the tenant is defining, and it can go and say, deploy the gateway and say what protocol that you are going to use. So one, we talked about high availability and resiliency. The other thing is in terms of various types of connectivity. Balaji talked about BGP as the routing protocol in Azure. The same thing is available now in Server 2016. So that means I can have a site-to-site VPN gateway between my multi-tenant gateway Server 2016, and the remote side could be, again, Azure, or could be another data center of yours. This could be a simple going over internet, or you may have, like as a hoster, you can have allow your tenants to bring in their MPLS network, which is generally over GRE, and the same GRE protocol tunnel can be terminated in the same multi-tenant gateway. And then based on the GRE ID, the traffic could be then redirected to either the blue network or the black network of your tenant. And another thing is, if in a hoster scenario, like you may have multiple VLANs for various tenants, and those VLAN IDs can be configured up to the gateway also. So you can bring your VLANs and then give the connectivity to the individual tenant VNets. That way you can do that through VLAN also, right? So all these things are possible through this multi-tenant gateway. Then the other thing is load balancer. So we talked about VNet, we talked about security and things like that. Then edge gateway. Now how SLB works. It's basically the same SLB that is available in Azure. The same SLB concept is brought to our on-prem Server 2016. So SLB has a concept of a MUX. MUX is nothing but a kind of a load balancing the load balancer, right? So the way it can scale is because you have the ability to map the WIP to DIP. So when you have a virtual IP and it has to be, and you have multiple web servers behind that virtual IP, you have to, when the traffic hits the WIP, it has to then do the address translation and say instead of the destination as WIP, instead I'm going to translate it to the actual DIP address, one of the DIPs, right? So the natting need to happen. So now what we are trying to do is basically do the natting at the switch level itself. So the MUX simply sees the the traffic coming from the client, and you may probably have an edge router that sends it to the WIP. Now the MUX knows that, okay, this DIP is available in this particular host in that particular VM switch, so that it could send the traffic to the specific one of the DIPs, one of the VMs, and to its actual VM switch. So the natting happens there. The beauty of this thing is when the inside machine wants to return the traffic back to the client, the address translation happens at the switch. And so the traffic need not go back via the MUX. So the MUX is kind of a stateless. It can scale so many requests and without incurring high CPU utilization. It just sprays the traffic into the respective DIPs. That way you can scale. Again, this is Azure load balancer concept that we are bringing it to our Server 2016 SLB. And another scenario for the SLB is the earlier one, we call it north-south. Any traffic coming from the internet to your DIP address is called north-south traffic. In some cases, you may have within your data center, you have east-west traffic, maybe a web front end talking to a database layer. You can have the database layer represented by an internal WIP, and that internal WIP could have multiple database boxes. So in this case, let's say a web tier trying to talk to one of the DB layer. And so because it is going to be WIP, it is the first packet is going through the MUX, and the MUX says this is where the DIP for the internal load balancing happens. And then the return traffic comes back through the MUX in this case and say, hey, it is another destination is also internal. And since the MUX knows that these two are already internal, and it can send an ICMP redirection message back to the respective VM host. So what happens is subsequent packets, they don't have to go through the MUX. So it can scale really very well. So this is the concept we have in Azure. That's how it can do the hyperscale. The same scaling effect is available now in Server 2016 SDN, right? So the thing is, you can still do this with zero CPU utilization, almost null CPU utilization on the MUX. So you can add more MUX, you can add more WIPs, you can easily scale very well, right? All right. So we talked about networking, and then the same security what is available in Server 26 Azure. The same thing is available here in terms of the VNet separation, the distributed firewall capabilities, and if you want to have deep inspection with virtual appliance, with what we saw with the UDR, you can do the same thing in Server 2016 also. All right, a little bit more. It's kind of a repeat slide like what we saw in Azure. I'm just trying to say the same thing is available in Server 2016. And then the same user-defined routes, whatever was available in Azure, we are bringing it to your on-prem. The thing is, basically, you can have third-party appliances. Since it's all the same common API, whatever appliance vendor that Azure Marketplace supports, the same appliances can also be deployed in your virtualized environment in your on-prem. So that's the advantage of having common set of APIs between Azure and your on-prem SDN. All right, we talked about things, so I'm kind of running out of time, so I'm kind of rushing, but it's the same concept here. You can use the appliance for inspection or just for port mirroring and just for logging.
Just quick questions. Are you going to talk about this one with the Azure Stack tomorrow?
Azure Stack, I have a Friday session.
Yeah, Friday session, right?
Friday session, I will go not much into the deployments of appliances. I'm going to talk about how to create VNets and how to create your site-to-site connections and things like that. Okay. All right. So again, a quick thing. Without a firewall, what will happen? Because if one of your front-end server is compromised, the attacker could easily penetrate into your internal network and compromise your entire infrastructure. Instead, with the firewall lying on top of this subnets, you can define rules and so you can protect each layer of your deployments. All right. Similar to what we saw in Azure for high performance networking, we have some improvements in the NIC in terms of improving the throughput. And just to give you a history, in Server 2012, when it was released, we had something like a throughput of 7.5 Gbps through what we call the VMQ feature. And in Server 2012 R2, we introduced the VRSS for the VMs inside the virtualized environment, and it was able to scale up to 21 gigs. Now, we are able to offload the hardware offload the VRSS, and so we can reach up to 40 gigs of throughput. And basically, these are numbers, that pre-release numbers. It's all tested with a 40 gig NIC, and today you can even get a 100 gig NIC, so the thing can even go up. So another thing is we talked about saving cost. In Server 2012 R2, we had to have two separate NICs, one for your RDMA traffic for the storage traffic, and one for the actual VM traffic. So with the ability to pump data up to 40 gigs, now we are able to consolidate both the RDMA traffic and also the VM traffic into the single NIC. And that way, we have high throughput available, and we are reducing cost because you don't have to have multiple NICs now. And you can pack more VMs into the host because we are able to do hardware offloading. And on top of it, we can also have some kind of a cost policy and say how much bandwidth you want to allocate for your RDMA traffic and how much is for your VM traffic. Let's see, how are we doing on time? Okay, so the reason why I was asking is I had a demo for Server 2016 also, but it's more of an animation thing. Just trying to conclude because lack of time. Basically, these are the challenges we talked about in the beginning, like how do I bring agility? Because you are going to do that through the controller in a software-defined way. You can create VNets, you can create subnets, and you can have your security policies all deployed in a matter of seconds. And then you get the same security that you would normally have in your on-prem with physical infrastructure or physical firewall. Now you can have a virtualized distributed firewall throughout your deployment. And because of the high throughput that we are able to achieve, we can pack more VMs in a physical host, and so you can reduce cost. So these are the challenges. Server 2016 solves these challenges. And if you have any questions, you can ask us. So how are we on time? Do we have time? Oh, okay. All right, thank you, guys. I think you will get the slides. In the slides, I have some animation slide on what are the various steps to do this deployment in Server 2016. And our Server 2016 TechNet page also gives you templates to download and use that to deploy your SDN through SCVMM also, right? I'll be here, so if you have any questions, please feel free to ask me, all right? And I have a session tomorrow. We'll talk more detail about Express Route tomorrow. And Friday, we'll talk about hybrid connectivity for Azure Stack, okay?